Hey Global Impact students, this is Mr. Ellinger. This lesson is on percents and change expressed as a percent. Our learning targets are to solve percent problems using proportions. We need to be able to solve percent problems using the percent equation. We need to find percent change. We need to be able to find the relative error in linear and nonlinear measurements. Essential understanding for the lesson: when the original amount and how much it changed is known, a percent change can be found. Also, relative error is the ratio of the absolute value of the difference of a measured or estimated value and an actual value compared to the actual value. So here are three examples of percentage type problems, basic problems. They're slightly different from one another, but they can be solved one of two ways. You may know a shortcut or an algorithmic way to solve these, but let's look at how you set these up. Let's look at ways that you can solve these problems. If you don't remember the shortcut or you don't remember the trick, you have something to fall back on. So the first one says, what percentage of 90 is 54? So that question is actually asking you for a percentage. The second one says, what is 25% of 144? So they're asking you to find a part of 144. 30% of what number is 12.5? So the two ways that we can solve these problems, the first one involves a percent proportion, and this is the method that I actually prefer, and I'll talk about why. But the percent proportion says you can represent A is P% of B using the percent proportion shown below. In the proportion, B is the base and A is a part of base B. So we have the algebraic way of setting this up. A over B equals P over 100. That's a proportion. And then we have an example there. What percent of 50 is 25? And they show you how you would set that up. The thing to remember is, a way that I always remember this is, I'm always going to do part over whole equals percent over 100. And remember, we always know that a percentage is out of 100. Okay, we can have percentages that are over 100%, we can have percentages that are less than 100%, but if either the known or unknown percentage goes over 100. We also have the percent equation, which is just a variation of the percent proportion. One thing that's missing in the percent equation here, if you take a look, is we have the equation, the percent equation is A, the part equals P percentage times B. And the one thing that we have to remember here, percentage is like if you're working with 30% in a problem, this is actually useless in a calculation. Okay, the 30%. If we're trying to find 30% of a number, we actually have to convert the 30% to a decimal, which would be 0.30. So what you don't really see in the percent equation is that this 30% really needs to be thought of as 30 over 100. Okay, and that's why I prefer the percent proportion, because that 30 over 100 is built into the proportion. You don't have to think about, okay, I've got to change this to a decimal. It's already happening in the percent proportion. Okay, so the three types of problems again, if we're asked to find a percent, here's an example. Here's how the proportion would look. Here's how the equation would look. If we're asked to find a part, this is what how the problem would read. This is how the proportion would look. This is how the equation would look. And if we're asked to find a base, this is how the problem could read. This is how the proportion would look. This is how the equation would look. All right, so let's go ahead and do these three examples that I introduced a few slides ago. What percentage of 90 is 54? This is the first example here. If we remember, part over whole equals percent over 100. What's the part? What percentage of 90 is 54? So 54 is a part of 90. We're asked to find the percentage, so we can call that X, or P if you want to call it P for percentage, that's fine. We know the way we solve a proportion is to cross multiply here. So we're going to multiply diagonally. 90x equals 5400. Okay, the way we solve this is divide both sides by 90. So x is 60. What percentage of 90 is 54? The answer is 60%. All right, second example here. What is 25% of 144? Again, I'm going to use the proportion, 25%, that's our percentage. They're asking us to find a part of 144. So our unknown is actually the top, the numerator, the top of the left fraction in our proportion. The percentage that we have is 25 over 100. And again, percentages as is are useless in calculations. They have to be divided by 100 or converted to decimals, either way. If you take a look at this proportion here, if I go ahead and go back up here to, we're finding a part, right? Finding a part. The equation in finding a part would be the part equals the percentage times the whole amount, the base. So here, if I just take this proportion and rewrite it a little bit without doing any calculation, if I want to isolate x, I would just multiply both sides by 144, which would give me 25 over 100 times 144. Again, this is p percent. 25 divided by 100 is p percent. Okay, so you can see they're equivalent to one another. They're just written in a different form. Okay, so I just wanted to show you that. So the way we solve this proportion is to cross multiply. X times 100 is 100x. 25 times 144 is 3600. Divide both sides by 100, we get x is 36. So 36 is 25% of 144. And there are other ways to do this problem. You know, we could say, oh, 25% is 1/4 as a fraction. So 1/4 of 144, I know, I just need to take 144 and divide it by 4. That's 36. So, you know, there's other ways to do this. I'm showing you, again, this is a way that you can do these problems no matter how it's set up, how it reads. Part over whole equals percent over 100. So here we have 30% of what is 12.5. So here you're being told the part. Trying to find the whole, we have the percent over 100. Cross multiply. 12.5 times 100 is 1,250. And when we divide by 30, we get 41.7. Not exact, but to the 10th. And I would go to the 10th because here I'm given a number in the 10th, so I'll just put my answer in the 10th. So there's our 3 examples worked out, all using the percent proportion. One application of percentages is to discuss percent change. How much is an amount changing in terms of a percentage? So the percent change is the ratio of the amount of change to the original amount. So an equation or a formula, we would have percent change, call that p percent, equals amount of increase or decrease over the original amount. Amount of increase, the way we calculate that is we get the new amount minus the original amount. The amount of decrease equals the original amount minus the new amount. Now, if you look at those two, what do we know about those two? Why, when we want to calculate the amount of increase, why do we do new minus original? And then when it's decrease, why do we do original minus new? Why do you think that is? Well, the reason that is because in both answers, if you will, both values are going to be positive values. Okay, positive values. So without having absolute values in here, this is how we can assure that we'll get positive values. Change, we can always talk about it being a positive value. So here our example, the average monthly precipitation for Chicago, Illinois peaks in June at 4.1 inches. The average monthly precipitation in December is 2.8 inches. What is the percent decrease from June to December? Percent decrease, percent change, p percent is what they call it. So a decrease, we're going to take the original amount minus the new amount, and that gives us 1.3. So the amount of decrease is 1.3 inches over the original amount, 4.1. P percent is 0.317. Now again, this is where we have to think. The percent change, or the amount of change, is 1.3. Is 1.3.317% of 4.1? If you think about it, I mean, 1.3 is about 1/3 of 4.1. 1/3 as a percentage is 33%. This is not the answer. And again, this is where this p%, again, back from our original problem, we have to do something here. Okay, p% really means p over 100 equals 0.317. Thinking back to our percent proportion. So the way that I would solve for p to find the actual percentage is to multiply both sides by 100. So this is 31.7%. That's the percent change here. So the monthly precipitation in Chicago, Illinois from June to December is approximately 31.7% decrease. Another application of percents is what we call relative error. Relative error is the ratio of the absolute value of the difference of a measured or estimated value and an actual value compared to the actual value. So this is a similar type concept to what we were just looking at in percent change, just a different context. So here our formula, we have relative error equals the absolute value of measured or estimated value minus the actual value. So here we're going to take the measured or estimated minus the actual. Every time if we get a negative result there, the absolute value kind of resolves that. So we know that this is always going to wind up being a positive value. When relative error is expressed as a percent, it is called percent error. So here's how we use this. It says you think that the distance between your house and a friend's house is 5.5 miles. The actual distance is 4.7 miles. What is the percent error in your estimation? Okay. Now this is a pretty harmless example of percent error, but percent error has lots of applications in the real world, in the business world, manufacturing. You know, a lot of times you're working under certain restrictions or constraints on how big an item can be or how much it can weigh when you're making it and packaging it. And a lot of times the things that you make or produce have to fall within certain limitations. So relative error gives you a context for how that works. Okay, so let's go back to our example here. Our measured or estimated value, you estimated, was 5.5 miles. The actual value is 4.75 miles. We'll take that absolute value, put it over the actual value, 4.75. 5.5 minus 4.75 is 0.75 over 4.75. So the relative error here, 0.158, rounding to the nearest thousandth. So it's asking us again, what is the percent error in your estimation? Percent error, this value right here is not a percentage, so we have to multiply it by 100. So the percent error is 15.8%. All right, we'll see you next time. Hope you guys have a great day.